Okay, so today we're going to go through some basic differentiation. So most equations that you come across when you start off with this topic come in the form of y equals a number times x to the power of another number. And when we differentiate, the notation that we write is dy dx. It could be different, so you could get something like y equals a times b to the power of n, where b isn't a number, b is actually a variable. Then if we would differentiate that with respect to b, it would simply be dy on db. So in this case, when we're differentiating, going back to here, what we do is grab this number up here, n, and then bring it out towards the front. So we get n times whatever we had there before, which is a, times x to the power of n, so our old n, minus 1. Now, I know a lot of people get confused when you see a whole bunch of letters in an equation, because, let's face it, we're all good at maths before letters got introduced. So, we might go through some examples. So, something that you might start off with is y equals 2 times x to the power of 3. So, if we're to differentiate it, we're differentiating y with respect to x, so we write our dy dx, and we bring down our numbers. So in this case, if we were to liken this equation to what is up here, you can see that a would be equal to 2 and n would be equal to 3. So if we were to follow this equation here, we could simply just substitute. So we bring that number down, 3, we multiply it by the number we had, which was 2, and we multiply that by x, then we put n minus 1. So 3 minus 1, no prizes for guessing, is 2. So you end up with 6x squared. So that's essentially our differentiated form of this. So once you get a lot of problems done, you get pretty used to it. So other ways that you could see a question as are, y equals minus 7, x to the power of minus 4. Now for some reason, when we get a minus in there, people, just start getting scared. Minus numbers, oh dear, what are we going to do? So in essence, this is the exact same thing. It's not too difficult, and once you get it, it won't be too hard. So in this case, our a is equal to minus 7, and our n is equal to minus 4. So what do? The exact same thing. We bring down the minus 4, times it by the minus 7, times it by the x, then we go n minus 1. So what's n minus 1? Minus 4 minus 1 is minus 5. And we end up with minus 4 times minus 7, which is 28, times x to the power of minus 5. Nice and easy. So we've done it with a positive number, we've done it with a negative number. Let's this time do it with a fraction. So say we had y equals minus a half times x to the power of 3/4. So what will we do here? Well, no prizes for guessing, it's the exact same thing. So we get our number up here. So what do we have here? We have a equals negative a half and n equals 3 on 4. Bring down our n, which is 3 on 4. Multiply it by the a, which is negative a half. Multiply by x to the power of 3 on 4 minus 1. So 3 on 4 minus 1 is 3 on 4 minus 4 on 4, which is equal to negative 1 on 4. So it's just going to be negative 1 on 4 here. And so we just expand it all out. 3 on 4 times negative a half is negative 3 on 8. Negative 3 on 8 times x to the power of negative 1/4. And that's our solution. Some people might ask you to bring the indices to the bottom. It doesn't really matter at this stage, as long as you get the differentiation part of it. So we've gone through fractions, we've gone through the negative numbers and positive numbers. So let's go through when we put them all together. So perhaps we have an equation like y equals 2x to the power of 5 minus 3x to the power of minus 2 plus 5x to the power of 2/3. So what do we do when we differentiate it? A lot of people I see would sit there and cry because that looks really complicated, but it's really just the exact same thing. We differentiate this one, then we add that to the differentiated form of that, and add that to that. So we can do it all in one fell swoop. So we get dy dx. You bring this number to the bottom. So in this case we have 5. Bring that to the bottom. We get 5 times 2 times x to the power of 5 minus 1, which is simply 4. And for this bit, we get, we have minus 2 times the number that we had before, minus 3, times x to the power of minus 2 minus 1. Minus 2 minus 1 is minus 3. And then for our final line, running out of space here, we have this number coming down, so our fraction coming down, 2/3, times the number that we had there before, which is 5, multiplied by x to the power of 2/3 minus 1, which is negative 1/3. And so when we simply expand that all out, we get 10 x to the power of 4 plus 6 x to the power of minus 3 plus 10/3 x to the power of negative 1/3. So basically we've gone through all the forms of differentiation for this, and that should give you a fairly good idea. So give it a shot yourself, see how you go, and good luck.